Yeah. Well, he's not. He's not talking.
Oh, we started live streaming.
Yeah.
Hey.
Hey. So
How'd the conference go?
I feel like he can't hear us right now. Can you hear us,
that might be
Luke?
the case.
Can't hear you now.
Everyone hear me?
Can hear
Yeah.
you now, yeah. What about hearing us?
I think it's the wrong mic, maybe.
Yeah.
Oh yeah, it could be his like laptop mic. But yeah, I didn't end up going to the conference either this year. Just not super interested in attending virtual conferences personally.
Yeah.
No,
Yeah.
same.
Same.
Definitely looking forward to the next like real one there is. But
Speaking at virtual ones isn't really the same either.
yeah,
It's sort of like I feel like you sit up and work on your presentation for a while, and then sort of getting to go there and speak to people and actually do it is the payoff. But then when the payoff is sort of just like sitting there and talking in front of your computer, it's not the same.
yeah. I was always curious about like how that looks or feels from the speaker perspective. Seems like it would almost be like you're talking to yourself, kind of. You know, I'm not sure like how much of interaction with the audience there is. But.
Yeah, pretty much none live. It's like
Yeah.
a Zoom call.
Yeah, there was none. Like the only indication was the staff for ElixirConf. Like, and he turned off his thing. So like at least I knew Ricardo could turn his video back on and like wave if something wasn't working technically. The biggest thing was that the site that Jim made, when a new track starts, it autoplays. So I had turned it off and paused it, and then like the tracks for my slot started up, and I could hear them, and so I had to just like mute my entire computer so that I didn't hear the other track talking.
Oh no.
And it turned out at the end, I missed probably what the staff said. It probably wasn't important, but when I unmuted, I then could hear myself because I was the last one talking, and it was there's a delay, like a big delay, like 10 seconds or so, and so that was really weird. But yeah, I was expecting it to be weird because one time I tried to hold the Austin meetup remotely, and it just felt weird not knowing if you were talking to anyone. But having that one person on Zoom knowing that they were in the call helps.
I had the live stream of my talk on another screen, so like I could see that it was actually like going on.
That's a good idea.
Yeah,
I heard there was I heard some people with all these virtual conferences started like pre-recording their talk and then like playing it and then answering questions while it happened.
Oh, that was just an option Jim gave because he wanted an international audience.
Got it.
I think there were two Japanese speakers. The one that Zaki pre-recorded, but the other guy I don't think did because his Twitter seemed to indicate he was awake. So I'm not sure if he was giving the talk live or if he recorded it and then he was just answering questions live. But he was up. The pre-records were like the recent, which is how you view old talks, didn't work. And so like I can't see Zaki's talk right now, which is annoying. I don't know if Jim fixed it. I didn't check it again today.
And there was some technical difficulties, or at least I saw something on
Yeah,
Twitter.
so Nginx crashed because it wasn't configured for enough connections or something. So it wasn't. Once again, it was not Elixir. Once again, Elixir DDoS other tech stacks. But yeah, Jim mentioned like it's like multiple hundreds of RAM of like the box he had running the conference.
Wow.
So he ups. So he like paused the conference for 2 hours and then like upscaled Nginx's config and like the RAM, and then
So
it was fine afterwards.
He just did the entire streaming setup himself.
Kind of, sort of. It was the actual streaming was Zoom. You're allowed to send the data wherever, and so he sent it to Mux, and then but it wasn't. So the video was Mux, but like the site itself still kind of hosted it. So I don't know if that meant that like the video stream was probably an external URL going to Mux or something, and then it was just. I'm not sure how much of it passed through his site and how much of it was Mux. He seemed to imply that most of it was Mux. Most of the work was Mux.
If Nginx crashed, maybe it was doing like Nginx, doing it through Nginx.
Yeah, it was something to do with the connection. So like Nginx was still proxying the Elixir server.
Got it.
Well, never mind. Good it went well.
Well, so there's no Q&A session or anything, but were people reaching out with questions and stuff? What was the?
There was Q. Well, there wasn't a separate Q&A. That did not happen. They ended up. Oh, I forgot to update you, Paul. That like they ended up restricting it to just the Phoenix people for Dockyard, not like general everyone Dockyard, because like he couldn't figure out how to explain that. And so there was 2 Q&A. Honori, who like, is, I think he had one of the nominations to be on the Elixir Erlang, the Erlang and Ecosystem Foundation this year. Actually, he had a question about it, and it was just clarifying like whether we're supporting NIFs or not, and saying that like no, we're writing BIFs right now. We're not, and the NIF interface wouldn't really make sense because C version is actually less safe than our Rust version, but that we might support it. We might support a shim later on, but not now. And then it'd just be safer to write in Rust. Because one of the questions was like, could you use Rust? I'm like, well, it doesn't really make sense because you can write directly in Rust. You're not trying to wrap up unsafe C API. So those were the questions there. I didn't end up going to it because it took a while to start, and so like I didn't know it was actually happening. I thought maybe there was like a problem was set up, but the later after party on the first day, I guess Brian fielded some Lumen questions, but I don't know what they were because I wasn't there.
They were more high level on. Well, I mean, the first one was like when, right? And I mentioned 0.1 just released today, but I was not committal to any date, saying it's ready when it's ready. We want to make sure the team gets to the point where they want to get it to rather than rush out the door. I discussed a little bit on the web side of stuff where people are asking about like rendering and all that, and I went over again the hypothetical rendering.
Like the framework side of things, you mean?
Yeah, they're like, what do you think a framework would look like? First of all, actually, you know what? I still think there's this is a messaging issue. I think there's some confusion on if Lumen itself is a framework, and so I had to, go into like, no, it's a compiler. It's not a framework. I've got these questions from time to time on Twitter as well, so I can do some time to review like what the website says and the GitHub repo, just to reinforce that this is not a framework. And so the short end of it is that there is no real good. There's nothing we can tell people on when they can start using this professionally to build web applications right now, because it's not even like we're at the point yet of the WASM stuff, and then from there, what are we expecting in turnaround time on any type of rendering engine and framework? I still think that's a long ways off. It's not like if you guys had dropped WASM the other day that it'd be like 3 months from now when that would happen. I think this is like a cycle that could potentially take years to get through. Let community kind of determine and experiment with different solutions, let those solutions bubble up to the top, coalesce around pieces of it. The other thing that was discussed during it was what was it? Well, I think just like use case type stuff outside of web,
Yeah.
and it was just very briefly brought up, and there was a question out of why focus on non-web first instead of web, and I think I pretty much answered that it was just easier for the path that you guys took, and that web's still very much a compilation target.
I mean, it was basically just because we didn't have everything we needed in WASM initially, so we focused on platforms where we did have everything.
Yeah.
Yeah, I think it's mostly they
Yeah.
just don't realize how early WASM actually is. Like until you get
Right.
embedded and start following the community group, you don't realize that, oh, WASM isn't like certain big companies have used it, but it's not that ready actually.
Right.
Yeah.
Like you just have to go to the WASM web page, and you'll learn pretty quickly that there's still a lot of work to do.
But it definitely seems like there's a lot of interest out there. I did talk a little bit about as well, kind of our go-to-market strategy, in the sense that I recognize the idea around fatigue, like this as a concept. I brought up 2 years ago at ElixirConf. We had the keynote last year, and then Luke's his presentation this year. And I recognize that, at some point people, because they're not, aware of the details or nitty gritty, or they're just unaware of, the complexity of the project, do start to feel a bit fatigued by it. And the need to kind of hold back, discussions on it, so that when we are ready to kind of say, okay, now you can start building stuff, that's when the real messaging starts.
Maybe if we write like every now and then, like a post where we go over, okay, this is what we've been doing, and just like to actually like give some context as to what we're working on. So because
Right.
I recognize that as an outsider, it's really like pretty difficult to see that we're actually doing anything, I think.
Yeah. I mean, I think that would be an awesome idea. I mean, I don't know what. I don't know if Lars is on the call or not, or if the current website is set up in such a way to
Yes.
easily add blog posts.
Yeah, he's here.
But I mean, it could be something as, I don't know if the once a month frequency is too high, or once a quarter. Once a quarter would probably be easier for us to absorb at the moment, where it's simply like, Lumen quarterly update, and then just you could even like bullet point style, or just like, here are the things that we accomplished over the past 3 months.
I think we could change the website a little bit. Right now, we link to this meeting as the playlist on YouTube, but
Okay.
And we link to resources of like the talks just in like a general thing, but we could make it much more news feedy style, and like have and arrange it chronologically and like put the thing. I don't think GitHub pages can do RSS feeds. I don't know, maybe they can. But just do that way, have a more newsfeedy for this sort of thing, and then we could include the blog posts in there along with the YouTube link for these videos.
If if the PRs are written in such a way, we could probably just copy pasta out of the PRs, kind of like major feature drops, or if releases are going to come more frequently now that 0.1 is out, we can maybe even coalesce those blog posts around releases.
Yeah, I mean, every release that we do from this point forward will at least have some descriptive text describing what is new in that release or what was fixed. And I think that anytime anything significant gets released, we could write a post. Just, it doesn't have to be long, just a brief one like, hey, this is available now if you've been playing around.
Yeah. I think one question I had too was timing around, because right now the compilation, like the process for compiling Erlang to Lumen is in the Lumen compiler, like the command line tool, but Elixir to Lumen is a two-step process, right? Like you have to compile your Elixir code through the Elixir compiler out to Beam, and then use those files to run them through Lumen. Is that the process?
Essentially, yeah.
So the a slightly better process is working. Like what you have to do is you add the Elixir compiler and then Elixir Lumen compiler, and then that will spit out abstract files in your build directory, and then you could just run the Lumen compiler on that build directory, and it should just pick up the files.
I think people were asking about just a one-step process.
But we're not actively using that mix thing. I'd feel more comfortable saying that works if the integration tests use that mix thing, or like new integration tests start from Elixir, they run mix compile, and magically they get the binary at the end, and it's not like Brian saying you get the abstract files and then you have to run Lumen again, like the command line Lumen. Like they shouldn't know the command line Lumen exists. It should be the point that we get to.
Yeah, I think that's what people are asking about, if this is on the horizon or not.
Invoking that in the Lumen Elixir task is really simple. I mean, adding that support is pretty much just running that Lumen command, I think.
I mean, that's fine. It needs to be done before we tell people that
absolutely.
Use this instead. And then I would want, like I said, I would want to write some of the integration tests directly in Elixir. I don't know if I would switch all of them over, because like the Erlang errors, it's like much closer to being right, but I don't know, maybe.
I've been also meaning to talk to Jose about how we might be able to hook into the Elixir compiler as a backend that can directly take the AST produced by the front end and operate on that for a couple reasons. One, what?
You mean the quoted form? That AST?
Not the Elixir AST, the Erlang AST produced by the front end, because that contains better, richer source information than what we generate by going to the abstract format.
I think Jose would be totally for that. I mean, he's been very vocal in wanting to support the project, and asks me somewhat regularly, if there's anything that he can do on the Elixir side to help.
Yeah, Jose is supporting not just us. He's also a Patreon for Gleam. Like he's supporting all the language, like a bunch of other languages and a bunch of other stuff for the Beam.
Yeah, that's actually a good point too. Is that I think that the approach that we take is something that we want to allow us to support other languages without them needing to add, a bunch of explicit support to their front ends. One of those paths is by supporting core Erlang, which we technically support, but I don't know to what degree
it is.
EIR is.
It is. So, I mean, I have the front end, but it's like totally bit rotten at this point. But updating it shouldn't be that much work, because I was supporting pretty much all of core.
Yeah, and I think with that, we can support most of the other Beam-based languages. The main thing I'm uncertain about there is, to what degree source information propagates down into core, because that's one of the benefits, really. Yeah. I mean, we don't necessarily need to worry about producing great like front end syntax errors and things like that. But a lot of the errors that we produce are diagnostics from the compiler. Will produce snippets that show a little bit of the original source code. So we at least need good location information, and that also applies to like stepping through the code, debugging information wise. So as long as there's good source information in whatever we take as input, then that's fine.
Yeah, the test case, once we get up to it with Elixir, would be like, if we have a Phoenix view equivalent or something with EX, do we blame the template file instead of the view file that the function is compiled into? Because that's like one of the places I know where the mixing the file lines happens in actual Beam files and like affects the debugging. Is that if you compile
I mean, we support those directives, but
right, it should work. I'm just saying that if we drop to core and we lose that ability, then we know that something weird is going on. And
yeah, I mean, that's the question, I guess, is whether that source information gets propagated down into core. I believe it does as attributes, but it's been a while since I last looked.
It's like some half comment attribute thing. I'm parsing it out, but it's not always that good. It's a bit hit and miss, but
yeah, like they don't bother doing anything like fuse locations and stuff, so it's a little bit like
if we do core, will it potentially that the optimizations for matches and cases don't work the same because it's too low now?
I mean, we essentially bypass some of those things because that lowering's already been performed. There's still the translation to our IR, but
right. I'm just saying, like, if EIR was doing the transforms to make them more efficient, but above the layer that core happens, we might lose some of the optimizations if we support core.
I don't think it's like. I don't think that's going to be a major factor. If I don't remember, is pattern matching done before core?
Yes, I believe so.
Okay, yeah. Well, it's not going to affect us that much.
Or it's desugared by that point, but there's still like it's fairly high level. I think it's just combined, you know, all the different function clauses into one function. There is no case at that point. I think it's been basically reduced down to like the more imperative, like if this, then do this, otherwise branch here. But that might be a later pass, but I'm pretty sure that happens in core.
I remember. I think pattern match compilation is done on core, but I think the level where I took it in before was before pattern match compilation. Because I think I wrote the pattern match compilation pass before we added the Erlang front end.
The correlating examples I found just with quick checking still has case. But you're right, the multi-clause functions are turned into single functions with case statements instead.
Yeah, so there must be a pass on core that then transforms the cases into the more imperative form.
Well,
so that's good for us.
It's gonna map pretty much directly onto EIR as it is right now. So like updating the core front end shouldn't be that bad.
The other weird thing about core is there's redundant guards. So like all the things that don't have guards now have win true in core. So that's something like, I know you did the redundancy pass for the stuff already, but I don't know if that'll affect your stuff.
Our Erlang front end, that's the same. It just, all of that gets removed by the passes in the air. We don't attempt any optimizations or anything in the front end itself.
Yeah, and any constant comparisons and MLIR will also be stripped. So
I was on, I hung out mostly in the hallway tracks for LexiconF, and I was in the PepsiCo one for a while, and the conversation started turning towards like things people want in Elixir, and I bring up my usual like type safety, strong type stuff, and then I guess PepsiCo is actually consulting with Erlang Solutions, and so one of the lead devs, PepsiCo, mentioned, "Oh, Francesco has mentioned something about this." So I thought it was the Meow thing, and then all of a sudden, Francesco popped into the PepsiCo Zoom meeting. Apparently, Robert Verding is working on strong types on the Beam level, and I don't know how well advertised this has been right now.
There's a few efforts on this front. There's a talk that somebody's giving at Oopsel or something, basically that is another approach to strong typing on top of Erlang. That one I'm not a huge fan of syntactically, but at least it's something that he's made some progress on. I think that's fairly fleshed out, but I was waiting for the preprint for that to be released so that I could dig into it a little bit more. He has actually given a talk on that at like a couple of years ago when he first started working on it. So I'm not exactly sure what the state of that is. And then there's been some research on a couple different fronts on typing dynamic languages that I've been digging into. So I think that regardless, one way or the other, somebody is going to make that leap to releasing something usable.
My understanding, most of the efforts were on like the pre-compilation step, but if it's going to be on the beam level, does that eventually mess with what you guys are working on?
No, I mean, that would be a good thing if there's types at that level, because they would be primitive types that match types we would work in at the low level anyways.
When you're talking about strong typing on the beam level, what does that actually mean? Does it mean that he's doing?
He didn't expand upon it. Yeah, so I'm not sure. That's just a verbatim what Francesco said. Okay. He did not expand upon what that means.
Because that makes me sort of think that he's doing that they're just doing more typing optimizations on like the close to like beam assembly level, which is something I know they've been doing more type optimizations there. So
it's possible, but I was given the impression that this is going to be a system that would be available for all beam compatible languages in some way.
Like passing down type information to like type optimizations on lower levels, maybe. I don't know.
Yeah, I'm not sure. Again, Francesco didn't expand upon it. The context of the question was I was talking about, for development purposes, strong typing, and he brought up Robert Verding's effort. So I'm led to believe that his effort somehow could be related to like strong typing for developers. The other thing that was brought up too, I asked Francesco about. I mean, we heard about this a few years ago that Erlang or Ericsson was thinking about splitting like basically OTP off of Erlang into its own standard library to be pulled in as separate dependencies. And apparently that effort is ongoing and still it hasn't been abandoned. Like I heard about it like 2 years ago, and
yeah, it's when they introduced Rebar. I think they were planning to basically push all of OTP as packages to like Hex or something.
Yeah, apparently that's still happening. I'm hoping to get a little bit more information out of Francesco about it. All this led to I'm now on Friday, Hans. You probably saw I'm the panel moderator for your presentation at Code Mesh.
Yeah, the panel. Okay.
Yeah, so I'll be moderating that. Like Francesco just asked me on Friday if I could do it. So anyway, I think it's like you, Hans, and like 3 or 4 other.
Yeah, it's like I think it's like the micro beam or whatever the beam from microcontrollers guy. One guy from Ericsson, and then 2 others. I think I don't know.
What's the intended outcome? Just a smaller beam, or
I think it's mainly questions.
Yeah. I think Brian's asking about that particular compiler.
Oh, well, that would not all of these are active. Some of them were like experiments that mostly died off, as far as I know.
So it was Oh, okay. I thought it was like the main beam like thing where they want to make the different.
So there's Kenneth Lumen from Ericsson. There is Kristen Krab-Turup, Maxim Kabershenko, and Nicholas Axelson. And I think one of them were the microbeam guy. Yeah.
So this is
one of the person that did like the beam in 12 megs, that presentation?
I don't know if he did any presentation about it.
I think Kenneth London is the compiler team lead at Ericsson.
Yes, he's always the one who does the talks at the conferences with the updates, at least. So.
So if they made all those beam parts into packages, would that mean that the alternative implementations would have to do less?
Well, no, I mean, it basically just means that the emulator, the VM, is separate from the standard library and is basically just has to operate at the same level as any other package.
Also,
There's
allows
still-
packages to iterate much quicker on releases. They
Yeah.
don't have
There's
to
still
wait for
weirdness
those.
with like init.url is in a special directory in the OTP thing where like they expect it to ship. And so like even if they broke off higher level Erlang only packages, those ones that we need to mess with because they assume there's a file system or like the way the boot scripts are separate files would still be an
Are
issue.
you talking about the preloaded beams?
Yeah, preloaded. That's the name. I'm like, I can't remember the name. It's not built. Preloaded. Yeah, preloaded will probably still be there because like the C code assumes it's there.
Yeah,
Um,
it basically is there to bootstrap the system, so it's those things probably won't go away.
Yeah, so we will always have to maintain forks of parts of preloaded. Whether we have to do the rest is iffy.
Got it.
Yeah, and I mean, a lot of what's in the preloaded beams doesn't necessarily have to be actually implemented as Erlang code, but
Did we lose Paul?
Paul, we lost your audio.
my fucking phone. I hate this thing.
Oh, it's good. It went back. It went back already. You're good.
Yeah, like the preload beams don't have to actually be implemented that way, but the key part that's important is that they start the root of the supervisor tree. And some of those processes like the application master and so on don't live in the preloaded beams, but in like kernel or standard lib. Most of what's in the preload beams are setting up like the fundamental APIs for like file system access, network access, distribution, compression, things like that. It's just like loading up some of those core libraries. But most of that is not relevant to us. The only thing that is essentially the init.url. And we are essentially have a solution for that. Just depends on how we want to approach, some of that additional pieces. My thought is that, we provide an init that does essentially the equivalent of what the beam init does, in terms of starting up the root of the supervisor tree. But then from that point forward, pretty much everything works the way it works with the beam.
Yeah, and us overriding that and not depending on files. But one, we can optimize it, but two, clap is like a really heavy dependency in Rust, and like getting rid of clap so that we just have the pre-built object sitting in memory will save a lot of binary space.
Right. I mean, I guess that's changed in 3.0. I think it's no longer super
Okay.
heavyweight.
Yeah.
And Google also has their own pretty similar but a lot more lightweight argument parsing library.
Yeah, there's like 50 million ways that we can approach that. We probably don't even need it initially, but I think there's some benefit to having something there.
Definitely having argument parsing for changing the node name would probably be useful, because like that.
I mean, we need to take some of the same arguments that the current Erl executable accepts, namely for distribution. Yeah, but for configuration as well is pretty important.
We can probably just wing the configuration just to our own thing.
Yeah, I mean, I would like to have it at least accept the same set of arguments, so we can essentially drop in with a program that somebody's already used and have it basically work. But ultimately, we can provide different mechanisms that are richer, not as weird and sort of backwards as the Erlang configuration. One of the problems with the Erlang configuration, I mean, it's a problem and it's not a problem, but one of the problems is that it's Erlang terms, but it doesn't really have any good templating or any good way to operate with the file system at large. Like all the dynamic stuff you want to do, you essentially have to write shell scripts around starting up the Perl executable. So that's where like Distillery had shitloads of complexity around releases because of that. It essentially had to deal with all the dynamic configuration stuff as its own thing because none of that really exists in Erlang proper.
Yeah, emulating the full command line string that is passed to Erlang for Elixir is a pain in the butt. But like I did it for the IntelliJ Elixir plugin so that it can be customized. But like it is really complex and even more annoying on Windows because of the stupid Windows parsing rules for command.
Yeah, I mean, we can probably ignore flags that we know aren't relevant, things like that. The main ones that are going to be important will be things that are distribution related, configuration, and maybe like the start or run flags that say which function to actually boot the system with. But that's optional, honestly. I would be fine with being like, yeah, that's not really the way you'd use Lumen, so don't. But I think there's still some value in having that eval startup because if you build an executable that's got, several different commands as part of it, like why not let somebody call arbitrary functions in it? Like there's no reason why we can't do that. So, but it's not nearly as important as just sort of the core, like start the system, boot the supervisor tree, load all the configuration. Like those things are pretty much universal across every Erlang application. So we need to at least support those. And I guess if it's problematic for us to support those flags for some reason, which again, I don't think is the case, we can do something different, but I think we should at least make an attempt to support it as is. And then provide our own better features on top if we, decide that that's worth the effort. I think the one area where that probably differs is when we build for WASM, like the way configuration stuff is provided, like it makes way more sense to let the system be configured by like a JavaScript object or something, you know what I mean? Like,
yeah, when I was optimizing for size, I took clap out in WASM because it bloated it a lot.
Yeah, well, one of the things that I have yet to implement also, but got some of the infrastructure for that done recently is LTO. That's something we're not currently doing. But I got that set up so that at least I got it set up for the Lumen compiler, and I just need to like update a few things to have that work on Lumen executables. But that should also severely strip down the size of most of Lumen executables because they'll strip out everything that's not used.
Yeah, right now most of the test executables were like 16 megs, and I assumed that was mostly Rust because like our actual like assembly code is like 200 lines, which doesn't.
Oh yeah, no, like the code we actually generate is super small, but yeah, the vast majority of that is essentially the standard library because we're not doing any dead code elimination like at link time. So with that in place, that should bring that way, way down. I mean, we still use in the runtime a fair amount of, different APIs, but, at link time, it will have more visibility into what's actually used, what symbols are referenced, and be able to strip things out that aren't used. And a lot of that is what's in the core standard library. Like we're not using a ton of that stuff. Some of our dependencies might, but honestly, a lot of the dependencies we're using are very like task oriented. They're not frameworks and things like that are providing a bunch of functionality and then pulling in huge swaths of the standard library. So
I mean, probably the hash map libraries we're using probably also have a lot of code, because otherwise, how could they be using so much stack space? So that might be
They
a thing.
might, but I think it's target specific. So a lot of the areas where it generates probably more IR is going to be on targets where they can do things like SIMD and stuff like that. We don't necessarily need to support those features, so the config flags for those are going to basically be collapsing all that code into nothing.
We're just using hash brown, right?
Yeah.
Yeah.
But so is core now too. So like us not using hash brown doesn't probably save anything, although we probably compile it differently because then we Rust
It's gonna.
compiles.
I don't think that's where the bulk of the size comes from anyways. But I do think our dependency tree is a little bit deep right now, but that's something that we can address with time. Honestly, the more we can move into Erlang and out of our runtime or out of Rust, is the more that we can remove of our dependencies. And a lot of our dependencies are compile time for Lumen anyways. The runtime dependencies are smaller. And I think right now we're also linking in, well, that's the Lumen compiler, not to our executables. So yeah, it's not an issue. Talking about this C++ standard library. And we're dynamically linking against that in the general case anyways, unless you specifically say statically link it.
So I may have missed this when my sound was being weird, but has anyone do we think the Linux release is completely broke or just broke for like Ubuntu? Has it like
I mean, it is broken right now on my branch because of some changes I made, but I need to look.
I mean the one we put out where like no one could run it either under Windows subsystem.
Oh yeah, I'm not.
Or actual Ubuntu or like some derivative they said.
I'm not 100% sure why. Hans, you're running a Linux laptop. Have you pulled the Lumen release and run it? Does it blow up for you?
I don't think I run the release, but I've built it myself, and it doesn't work like natively on my computer. I have to still build it in the Docker container. I can try to release if you want.
Okay, so it could be. I want to say the Docker container. I mean, one where
there's something about that.
I'm pretty sure it's the set releases thing that's fixing it, like set alternatives LVM.
Okay, well, I mean, so that's an issue if Lumen must use like the Clang linker to work, we're going to have to make sure to ship the Linux one that way.
So I on my branch right now, I have changes that address that.
Well, that's cool then.
It forces the compiler to be built with our LLVM, regardless of where it is.
Oh, that's
it's
great.
on the system, it uses it.
I could try that then if you want.
Yeah, do that. It also uses the linker. So
okay, as a double check to make sure that works, you should in the Docker container turn off the Etsy alternatives, so that to make sure that it's not necessary to make it work.
I think there's probably some compilation differences as well. Like one of the things that I'm seeing on my branch right now for the compiler is that it compiles Lumen just fine, but then when it compiles some of the executables, they're blowing up. Like something happened, like it basically blows up in such a way that we don't get anything meaningful. So I've been planning to boot up a Docker image and see what the deal is there. Basically, yes, it's something in the runtime that's failing.
That is true. So like some of that Etsy alternative stuff, it doesn't blow up Lumen building. It is only blowing up things Lumen builds or during Lumen building. So like it's a very indirect side effect of having to do the Etsy alternatives.
Building itself works just fine on my computer. It's the actually running it, then the executables. When linking, it blows up, I think.
It compiles the file just fine, but it fails to run the executables. So I need to look at that a little bit further. That could still be, like, the linker is not the problem. The problem is the compiler that's used. So we need to make sure that the IR, is being, well, that's with LTO, but in general, we want to compile with a very recent CLang. Linker wise, it's much less important because we're not using like any sort of fancy linker features unless LTO is enabled. But again, that's not the default. So, and that has more to do with when we're actually linking executables and not like a runtime thing. So if there's a problem with the linker, at that point, it's going to blow up at link time, not at runtime. But I think there's probably some, the way that the code is actually being generated is some assumptions being broken somewhere. I think that's what's causing these panics that I'm seeing. But as far as like the release that, we already dropped, like that, I think is broken because of, how we compiled it before I made those changes. So we definitely need a slightly better process for validating that, I think.
I was going to bring that up, of that we should check in whatever script you're using for release and have.
I did on my branch.
Okay, workflows probably just on master that run it, and then we would use the release artifact and then run integration tests with the release artifact. Not necessarily the same test, but like some tests that use the release artifact to prove it works. And obviously, if it turns out that like Alpine versus Ubuntu, and it's not just a general Linux problem, we would then have different documents, just different distro bases. But it's probably a general Linux issue right now.
Hey guys, I gotta drop off.
Okay.
All right.
Talk to you later.
Talk to you later. Yeah, I mean, for like Alpine and other muscle-based targets, like we should treat those as separate platforms because they really are. Debian-based systems are all going to match the same. Basically, anything that's glibc based, x86-64 Linux, like that's going to be more or less a uniform platform. So we can try a couple different of those.
Do we need do we need multiple Linux releases? So obviously we should do the.
Yes. Well, there's muscle-based and libc-based.
Right. So we should do a libc and a muscle, and we'll have to explain to people what the difference is, because likely what's going to happen is otherwise they're going to be like, I'm going to build an Alpine on CI using Lumen, and then they're going to deploy, and it's going to be muscle-based and not libc-based, but their actual servers are libc probably, unless their Docker containers again using Alpine. So like that might be an issue, right?
Yeah, I mean, if you install a glibc-based executable on a muscle-based system that does not have glibc installed, it will explode.
Right, but it's a thing that we're going to have to worry about people not realizing.
I'm not worried at all about people running Alpine not understanding that, because they fundamentally have to in order to run Alpine. But I am more concerned about people running like Ubuntu or whatever. They may not necessarily know the difference, but we can definitely resolve that simply by providing like .deb packages for Lumen for those platforms. And that's something I can set up. It's been a while since I last fired it up, but a coworker I worked with a couple of years ago was a Fedora maintainer, and he ran this tool that would take, an input script and essentially generate packages for all the different distros. Well, like Fedora, Red Hat sent to us, Debian-based systems, and I think one other, but I can use that on this to package our, executable for those platforms, and then we can just tell people to download, the appropriate package for their system. That's more foolproof because you can't install a .deb on Alpine. And for people that, we can call out specifically the, x86 64 unknown Linux, muscle executable is just like, call it like Alpine or something. But the main difference there is that it's a different libc and it's statically linked generally. that's sort of the convention for those. So. But in the near term, we can probably just rename the files to make it a little bit clearer what's going on. But we need to make sure that we fully have it working on at least Ubuntu or Debian before we worry about some of the rest of that. I think that my changes, at least on my branch, probably address that, but I'll need to fire it up in a Docker container and actually make sure that's the case.
Right. Are your changes, since they involve closures, going to fix the bug I saw where like the parameter doesn't get passed through multiple closures in a row? Like closures.
Probably.
Like
I mean, the changes on that branch now fixed so many different problems. I'm not sure exactly what the full extent is, but I can run that Erlang source and see. But right now, the only thing I'm doing is just making sure that any remaining test failures are addressed, and then I'll merge this and go back and take a look at some of those other issues.
And then one other thing, right now Lumen only accepts a single path for like, where's the source? I mean, there's the include path, but that's for like hurls. Can we do multi? Because for some of the tests, I want to have like a bundle. I want to have a directory with like the support libraries for the tests and also the init.url. And so right now I'm symlinking it so that they're all in one directory. But if I could just, list both directories and files, because we still have, -- to separate the LLVM arguments. But we only parse for one. Would that break anything?
To have multiple directories, you mean?
Yeah.
No, there's no reason why we can't support that.
Okay.
I'll take a look and see if there's any reason why that wouldn't work. I'm guessing that you've tried passing multiple directories.
No, I just assumed that the docs were correct because I thought I passed two things once accidentally, like two files, and it like interpreted as an LLVM argument, but that was months ago. So I just assumed the docs were telling me the truth. I haven't tried it again.
That might just be an arg parsing bug then.
Okay.
Because it's intended to support passing multiple files or multiple paths as inputs.
Okay.
But they have to be the last arguments passed to compile.
Maybe that was
and it should take multiple directories as well, because it doesn't really distinguish between files and directories. It understands both.
And and the other like UX thing with Lumen, and I think this is a problem with the IR, Hans, and I opened it, is that there are times when I pass the arguments and the build directory exists and it says like, this is not a directory or file. Like it's an OS2 error, like it's an IO error, but I have no idea what file it cares about. Like there's not enough context.
Like the only thing that's handled in Lumen in EIR for that is if you do includes or something like that, and it errors that, and I think that shows it. I don't think that error is mine.
Okay, because it's coming out of the thing when we do libeir utils, and then it has to loop over the diagnostics. It's just printing that. And so like, yes, the Lumen code would know the path, but it would have to assume that any diagnostic coming from compiling one path always is that path name, which isn't true.
If it's coming in via a diagnostic from EIR, then it's EIR. I'll have a look at it, see if I can figure something out.
Yeah, I tagged you in the comment and said you might have to move it. But yeah, I fixed one of the other one. One of the ones with like relating to like the build directory doesn't exist. I now include the path or something. So that's clear, because always it's just like generically the file does not exist, and it's like which one.
Yeah.
Yeah, at some point want to make sure or revisit some of the front end stuff to see if the defaults still do what I expect them to do offhand. Like for example, I would like the defaults output directory to not just be the current working directory, but instead be like _build or something like that.
That's what I've been standardizing on.
Yeah, I mean, I pass it always explicitly, but that's just because I'm in a subdirectory.
This was on my to-do list, but I didn't open a thing to do it. Is we should probably make it that the output dir is made if it doesn't exist, because otherwise Lumen also errors. If you do output dir
No.
and the dir does not exist, it errors
It
out.
doesn't
'cause
do
it-
that? Oh. I thought I
Nope.
did that. I guess not. Okay, yeah, that's a good one. That's a good fix. If you have an opening issue for that, might as well do it just in case we forget.
Well, I'm technically on vacation right now. I just, since this was
Oh,
a
all
community
right.
meeting.
Sure,
I'm
no
allowed to
problem.
be there.
I can deal with it.
Yeah.
I'll just look at it right away then. How long are you on vacation for when you come back?
Oh, just a week.
No, okay.
No, I pretty much anytime I was awake worked the last month getting ready for the conference. You know, making sure I had enough test cases for you
Yeah.
and Hans to find the bugs so we could get the release.
No,
I
that's
will
been
say-
super helpful.
I will say that was amazing. Like the month before, I wasn't going to say we were going to be ready for release. So you two did great work. That was fucking awesome that we got a release out, even if
I'm
the
glad
list
we were able to.
Mac
Yeah.
one works. Other people confirmed it. The one bug that was about Mac was just he downloaded the Linux one. I don't know if you two saw that. So
Oh
it's
no, I
fine.
missed that.
Yeah, the Mac
Yeah,
one
I
is
saw
fine.
that.
No one has reported a bug on the Mac one, so we're fine.
Well, that's good. I'm glad to hear that. Yeah, it was definitely a hard push. I mean, honestly, I don't know about YouTube, but it feels like there hasn't hardly been a break since we started this project. So
Yeah, it always
been
feels
aggressive.
more and more in like the fact that good WASM support is now us pushing on a bunch of other people to do it is frustrating.
Yeah,
You know, like getting stack switching so that we can support it right.
I definitely thought that by now, some of that would have already been kind of taken care of. Part of the reason why I've been more interested in focusing on, standard platforms first is just because I wanted, by the time we were done with that, to essentially be able to turn and just focus our attention on WASM without having to necessarily do a bunch of groundwork first. But it's looking more and more like we're going to have to do that. But in any case, like, I think I have some ideas of how to approach that, but until we get this initial release of Lumen to a point where, you can actually build and run like some programs, some command line applications, I'm not super interested in focusing on the WebAssembly side of things until we reach that point.
I don't think it's a big deal until we at least have Erlang OTP working, because it has to be something that the normal language users can do.
I want people to start basically using Lumen for something to sort of justify its existence. And then, we can start to focus on extending support to other platforms, because with that interest comes more contributions, people that are also willing to help push some of those things forward. It also gives us a little bit more weight to be like, this is a thing that people actually care about. If you're going to implement these features, it's not just, for our own, benefit. It's for our community's benefit,
Yeah. Who would have thought, completely remaking the language would have taken years?
Yeah, I mean, I expected that it was definitely going to be a couple of years before we were like done, but it's taken a lot longer to get to this point than I was expecting. But part of that has been sort of the roundabout way that we took to get to where we are now. And we did spend a lot more time up front building out runtime support for like other platforms where we probably didn't need to. But the other benefit of that is that from the very beginning, we've sort of designed things to work for multiple platforms. And so supporting multiple platforms is not this huge, like, oh shit, a bunch of this stuff that we wrote assumes things about the platform. Like there's some of that at the Cogent level, but not very much elsewhere.
No, I mean, that was super important because, like, I don't know if, like, the runtime used to know the bit layout of shit before you did the type term thing, or the thing before type term. Like, that was the first abstraction over it. And, like, that means we totally would not be able to do 32 and 64-bit without every BIF knowing that.
But we basically got to that by, like, running into consistently hitting, like, multi-architecture issues, right? And if we hadn't spent you spent the time building out the WASM runtime, like, we wouldn't have found those issues, because that was where we honestly surfaced a lot of the 32-bit architecture problems. So it's been a roundabout way to get to where we are now, but I think it's worked out well because of that. We have a good foundation.
I feel like finally being able to run Erlang programs now is giving me a lot more motivation again.
Totally. Yeah. Same here.
I feel like we're hitting a milestone, and it's really like reinvigorating my motivation to working on the project.
I mean, it's definitely like where you can say like and test it in the beam and be like, this should work, like this should work. I mean, I have to change init to start, but like that's the one annoying part. Like I have to change it every time.
Yeah, I mean, the closer we get to having some of that stuff provided as part of Lumen, so that it's more like running RLC than running our own thing, the more it's going to feel like an actual replacement, right? Something you could drop in and compile other Erlang software with. The one thing that I needed to add to Lumen is some comprehension of like the standard application layout and like rebar to config and things like that. The main reason there being that having some way to sort of grok the project layout is going to make it a lot easier to drop it in and run it on like a real Erlang library or something. You know what I mean?
Yeah, I was thinking of that. I guess the mix thing gathers all the output together. But we're thinking about like converting an Elixir project. The build directory is still separated by dependency for the outputs, with like the weirdness of some of the Erlang dependencies put their beam files in their source directory, like not in their source directory, but they don't go into build. And so like,
oh yeah,
we're going to either have to the mix or like the compiler integration that Jose grants us is going to have to do that for us, or we're going to have the default Lumen compile be more used to like what's normal in the ecosystem, so it searches like the default like _ build and shit like that.
Oh well, that's really what I'm getting at. Like with Elixir dependencies, our approach has to be different because the way the Elixir compiler works is much more like compile time is runtime kind of a blend. We have to rely on Elixir really for that. But for all the Erlang dependencies, like we can directly handle the compilation for those. We don't need to rely on Elixir for anything other than telling us what the dependencies are. And then we can directly feed those deps into our compiler. And that's the one change I need to make in the driver itself is the way that I've got the compiler set up right now, essentially each module gets compiled separately and then they all get linked together. But I ultimately want to shift a little bit so that each application gets, like all the modules get linked into a single compilation unit or translation unit, and then applications get linked together. The reason being that it makes a lot more sense to compile, a single application as a library, especially for optimization purposes, because we can reason across function calls and things like that. Where right now, by compiling a single module, in isolation, we essentially can't infer anything about function calls outside of that module. The more global reasoning we have, the better.
Would you end up putting the LLVM level module to be like the namespace? So like the Erlang module init would map to the LLVM module init, and we wouldn't smush the names together anymore, or would the module name be not necessarily match the Erlang name?
Oh, I mean, the module names would still match. I think I see what you're saying, like what happens when you have a module with the same name and different dependencies.
Right, because like LLVM supports modules with names. Okay. Yeah, and
the way we'll need to do that is add some support for like application namespaces and the way that we generate symbols right now. One of the things that we're essentially assuming at this point is that every module is a unique name. That's not going to be the case. So.
I mean, we actually kind of want them to be mixed though, because if you think about it, we kind of depend on that for init right now and Erlang, because we have built-ins with that act like they're Erlang, and we have like init get plain arguments, which is a built-in, but init start is supplied by Erlang code, and we'll have the same thing with. Well, I guess once we use init Erl from Erlang OTP, we won't have init starts anymore. But like, it's sort of
right.
like how NIFs have to be able to replace some of the function names in a module while you still have Erlang code next to it. is like almost the thing we're doing here. We're like different.
Actually, one thing that just occurred to me is that aside from Elixir, on Erlang side, modules have to be unique anyway, so it's not really a problem. We don't need the namespace.
Yeah. Yeah, we just do the underscore stuff. And I mean, that's what I did with the test libraries I wrote. I just called them test underscore the way Erlang would. The different subsections.
Before I forget, do you think adding an intrinsic for constructing lists in reverse order, so like creating a list tail and afterwards populating the tail, would that be fine to add intrinsics for? That way I can generate more efficient code from the front end in some cases.
Yeah, I mean, anything around generating lists more efficiently is ideal. And honestly, I'm getting more and more inclined to spending some time like basically building an optimized form of lists, like a vector basically.
Yeah.
Because it's so common to have these lists that are small, could be either stack allocated or just like allocated way smaller space. I'm not sure what the best approach is for that.
I can't even imagine how much, how many cases it's going to happen where we're actually just like totally destroying the cache by doing it this way.
Oh yeah,
it's going to be really
not the Q&A and not the conference one, but one of the I can't remember. I think it was against the channel's Twitter, like the Get Lumen Twitter. There was a question about other types, and I said that you had thought about doing vectors before. So if you look at the replies on,
I'll have to check that out. Yeah, I mean,
someone asked about it.
The main idea that I'm having right now is that because of the way cons gets treated currently, it's possible for us to sort of signal that a reference to a con cell is actually a reference to the head of a vector, and then use that to optimize the layout of that list. And then that would allow us to join vectors together, sort of like a linked list of vectors. So if you want to like
do the rope thing that that
basically.
text editors did in the 90s. I don't know if they still do that or not, but
yeah, I think they do. It's pretty common. I know Adam was doing it as recently as a few years ago when I was reading some blog posts about how they structured that stuff. But honestly, the vast majority of lists, and I really want to add some profiling infrastructure for some of these things, because what I'd like to do is compile an Erlang file and then get a layout or a dump of this is how many lists of what size are present. You know, some of that would have to be done at runtime, but some of it, a lot of lists are put together at compile time. And especially the compile lists or compile time list, having vectors is super important.
I mean, every time we're iterating through a list, we're going through like indirection and doing several checks on stuff. It's going to, I mean,
yeah,
I have a feeling it's going to be like a lot quicker if we get something else going.
Really, the only benefit we get for the constant lists is one. I guess I didn't. Our constants actually go in the RO data section of the final binary. Is it that optimized?
Yes, but not currently with aggregates, because because of the way terms are encoded, there is no way for us to term encode a pointer at compile time for a constant.
That makes sense. I mean, the beam technically works the same way, where like you can't have constants point at constants. They end up just having like a very big constant, and then like they're joined together at runtime. So that makes sense to me.
So that's essentially what we're doing as well. The elements themselves are constants and would, yes, go into RO data or, you know, some appropriate section depending on the platform. And then the con cell itself is then constructed at runtime. But that's still like crazy inefficient compared to being like, oh, well, let's build just a vector of terms.
So I'm gonna add intrinsics for just manipulating raw concells, and then I can start using that in the front end, like to begin with, and then also I think there's a lot of like really low hanging fruit where we can just recognize the pattern of recurse over a list and then reverse it.
Yeah, so I'm not sure yet at what point we'll be able to do some of this analysis, but what I'd really like to do is, make more effort to essentially determine loops that, especially loops that operate on certain data structures, because we can do some really nice transformations down into very efficient code if we kind of get a sense of what is happening. And that's where also vectors can come into play. If somebody's doing something stupid simple with like a list of integers or something, like we can do fun stuff like actually lowering that to vector instructions and things like that. So that's not super important, but that's kind of what the, oh God, you know exactly what's working. Yeah, Pelame. Essentially what they were doing, except for they were kind of having to do that way as like a library, right? But we can essentially have that be pervasive and do those sort of transformations anywhere that we recognize loops. And we can do stuff too, like recognize like when certain like standard library calls are used, for which we can transform those calls into like primitive loops and things like that. I'm thinking like enumerating lists and things like that.
And I don't necessarily think we need to do this all. Like we can expose some of this to the user in a backwards compatible way as well, where we have sort of like a Lumen library on Hex or whatever, and then just have functions there that you can use as sort of intrinsics and mark to Lumen that here's what's happening. So we want this to error if ever. We want this to be a like list of integers, and if ever something not integer makes it into here, then treat that as an error, and then that's gonna work efficiently on Lumen, but then it's gonna work fine on Beam as well. It's gonna just compile to whatever code was there before because they're just calls to nothing.
Yeah. So like right now our OTP has a Lumen module in it for like things that are useful that don't exist. So like right now it is like is big integer, is small integer. So we could put other intrinsics in there to show that they're Lumen specific.
Yeah. So those I just made changes to on my branch to lower all those type checking intrinsics directly in the compiler. So they don't call into the runtime anymore for that.
Right, but did you? I mean, is big integer and is small integer is the thing I just made up for the test? Like you pulled them in? Like they're not ones built into Erlang. I just made them up.
Oh, is integer is a guardian.
Right. So the problem is I need to make sure that the tests that like care about that it bad args for each type specifically, and also for the math ones, how you know that like promotion to big integer happens. So like I have checks.
Oh, I see what you're saying.
True equals is big integer, just say that it actually is a big integer.
Oh yeah, I wouldn't lower that to an intrinsic, but that makes sense to have that in the Lumen utils module just to make that super helpful for tests. Are there other things in there like that would be either useful to lower as things in the compiler?
I did something in those other two. Let me see.
So should I when making the list raw list manipulation intrinsics, do we want them as like actual like dynamic op intrinsics, or do we want them just as function calls to? I mean, they're unsafe, so maybe making them dynamic ops.
I mean, yeah, I think it's better to have things like that really be like operations instead of calls to functions that sort of magically behave differently. But
yeah,
I mean, it's fine to represent them that way if it just makes it a lot easier. But if we can have specific operations for those, it just makes the lowering and cogen a lot more straightforward.
Yeah, that's really easy now with the dynamic ops, so I'll just do that then.
Awesome.
Yeah, the other stuff in Lumen right now is log exit 1 to turn off logging so that I didn't have to
I've seen
around the log, and the other one is the special applies that unpack the arguments when we're spawning closures. So like apply to, and apply to /1 and apply 3/1, because we just pass in the one argument that those two use, and that's how we get the bad arity arguments with the correct stack trace of blaming apply to or apply 3.
Yeah, there's something. Oh fuck! I was stepping through some code and something was weird in there. I'm trying to remember what it was. More of an optimization opportunity than anything like incorrect. Fuck, I'm spacing on what it was. Well, when I get a chance, I'll try and dig it up and open an issue or something. Mainly, it seemed like it was doing a lot of redundant work that didn't need to be done. At least for the native backends, like it might be different for the Rust-based tests. Shit, it was last week sometime. I've totally spaced it in the meantime. Not super important, but when I pull together whatever that was, I'll send you a message and just get your opinion on it. But yeah, as far as other changes go, one of the main ones that I made was essentially refactor the way I was using types in MLIR so that it's much stricter about types. One of the things that enables a lot more optimization opportunities, which has pretty meaningful impact even in some of the small code examples. But the main thing that I was catching by doing that is some correctness issues. So what triggered this is when I was looking into one of the bugs that had been opened, maybe is around closures or something else. I don't remember exactly, but I realized, oh, that's what it was for comparisons. Like a logical and it was having some problem with. The way that it was getting transformed was like generating a lot of just gross IR, but also doing some incorrect transformations because everything was being cast to term basically. So everything was just sort of dynamic and there was no real sense of provenance for the terms. So I spent most of the last week reworking how all that stuff works. So now we only cast when it's absolutely clear that it's required, like it's demanded by a function call or something.
Well, yeah, we only had the term thing as a workaround for the calls, remember? Because originally it couldn't figure out that it needed to be a term, and the calls were like, I can't do anything.
Right. The thing is that there was a lot of those casts were infectious, and they were essentially like everything was term all the time. And so now types get propagated in a bunch of places. That gets factored into a bunch of the canonicalization and optimization passes that I wrote.
Wait, does that mean we have constant time to like add now?
Yes.
Nice.
Constant folding of basically anything that's like immediates. So integers and constant booleans. Constant booleans is the biggest one because a lot of the IR that was generated, like if I looked at it, I could tell that at compile time we could fold not only those constants, but then eliminate the branches that were never going to be called. But because of all that casting that was happening, the IR was just basically fucked. So now it is crystal clear. All that stuff gets propagated.
How did you break it up? Did you make it so like I know the way we regenerate it was like the better term and immediate cast. You just make that be on 2 lines, so there's 2 different SSA variables for it, or is it more like you inject the cast a term when it's necessary?
Right, exactly. It's deferred all the way until we're lowering to LVMIR. So only when we realize that we're passing a concrete type to a opaque term type, like basically function calls, do we perform a cast. And then that cast is only used specifically as an operand for that call and is not used elsewhere. And so the main benefit there is that in a bunch of places, we no longer need to perform casts at all because that type information gets propagated. And that also plays into essentially all the constant folding stuff. So, and not just constant folding, but also allows us to know, like if we unpack some term because we know it's some type, we now have the type term to operate on. So anything
Like if you
that's a
well, I
path
guess
that operates on those types. It
is
knows
integer
what the
doesn't
type
work,
is.
but like if you do is float, all of a sudden you know it's a float after that point.
Right. I haven't written the pass that actually propagates that kind of contextual knowledge, but
Oh,
it's super trivial to do that at this point.
I mean, doing a different PR, like right now, probably fixing the Linux.
No,
code is
it's
more
not
important.
important, but essentially these changes enable us to do that now. But there is a bunch of places where that type information is propagated, and that namely is when we're constructing terms in the IR anywhere. So anytime we do type construction now, that type information flows to its uses. And that allows us to do, optimizations like allied type checks and things like that if we know that we're working with a term of a particular type. There's a lot of optimization opportunities there, but for the most part, the main thing that I was trying to catch is places where we're doing things incorrectly, essentially passing the, there were a couple places where, because of the way the casting was implemented, we would end up passing an immediate, like encoding an immediate twice, or like encoding an immediate, decoding it, and then passing it somewhere as a term. But it would now be not encoded anymore, and a few other weird places like that, where that can't happen at this point. Aside from just eliminating a bunch of the casts, one of the main things there was really leaning into the distinction between boxed values and pointer or ref values. So anytime that we have a box value, essentially is treated like a term, except for a term that we know the type of, where anytime we're operating, like doing get element pointer or loads or stores, it's operating on a pointer or ref value. The main thing that's important there is it allows us to distinguish at compile time whether a term is already encoded or needs to be encoded. So when we do a cast to an opaque term of a type like that, we can tell what we need to do with it. There's a few other types that I would like to add, namely to distinguish between some of the other types where it's a little bit muddy sometimes, just to add some clarity in terms of what sort of optimizations we know that we can perform without having to do too much contextual reasoning. And one of the things I really am looking forward to is once we can propagate more type information from the front end down into the compiler, I think we can do some really interesting stuff there.
I've already started doing like basic typing in EIR, and I'm planning to work on it more once. Like what I'm working on right now is I'm like several levels deep in a rabbit hole. So right now I'm fixing like float semantics and constant evaluation in the front end. So once I'm done with that and reach the top again and manage to like finish this up, then I'll start working on floats hopefully, if nothing else comes up.
Yeah, it'd be like the more type information that we can dump to the back end, the better.
I gotta go. So
sure.
do you want to end the meeting because the live stream's still going?
Yeah.
I'm mostly done, I think.
Okay.
All right, we'll talk to you later.
Talk to you later.